Okay, we're going to go over some of the problems in the Algebra 1 Honors Review Packet. Now, some of them I did for you in the packet, so I'm going to pick ones that I didn't do for you in the packet. So on page 1, number 3, it's the absolute value of 2n plus 10 plus 5 equals 27. Now, when we solve an absolute value equation, the goal is to isolate the absolute value sign. So I'm going to subtract 5 from both sides, and I get the absolute value equals 22. So this means either the absolute value of 2n plus 10 equals 22, or the absolute value of 2n plus 10 equals negative 22. And the reason is, if I was to cover this up and say what could be in the middle, you would tell me either 22 or negative 22. Because the absolute value of 22 is 22, and the absolute value of negative 22 is 22. So now I just solve both of these equations. 2n equals 12, n equals 6, 2n equals negative 32, n equals negative 16. So the answer is 6 and negative 16. Both work. If you plug them back in, you see negative 32 plus 10 is negative 22. The absolute value of negative 22 is 22. 2 times 6 is 12 plus 10 is 22, and the absolute value of 22 is 22. Okay, so now let's move on to graphing an absolute value function. So, to graph an absolute value function, y equals negative 3, x plus 1, absolute value x plus 1 plus 3. First, I identify the vertex. Now, the vertex is the opposite of the number you see inside the absolute value with x, so that would be negative 1, 3. So negative 1, 3 is my vertex. Negative 1, 3 is your vertex. Then we go over 1, up 1 times negative 3. So that means I go over 1, down 3. Over 1, down 3. Or, even better, think of it as a slope, negative 3 over 2, down 3 over 1 in both directions, down 3 over 1 in both directions, down 3 over 1 in both directions. And this is a reflection and a stretch, and we start at the vertex. Okay? Now, let's look at, okay, first we're going to look at 9 through 12, and I'm going to tell you skip 9 through 12. They are absolute value inequalities. We did not learn them. Okay, so let's look at number 14. Number 14, it says solve by factoring. Okay, k squared plus 32 equals negative 12k. Well, first I put this in standard form. Plus 12k plus 32 equals 0. I look for my magic numbers. Two numbers that multiplied equal positive 32, but add up to positive 12. And 8 times 4 equals 32, but 8 plus 4 equals 12. So my magic numbers are 4 and 8. And because this leading coefficient is 1, this is a type 1 factoring situation where I can put k and k, because the only two variables that when multiplied equal k squared are k and k. And then I just add my magic numbers equal 0. I double check it. K squared plus 4k plus 8k is 12k plus 32. So this means k equals negative 8 or negative 4. Okay? So then we turn the page and let's look how to solve an equation by taking square roots. So this should be fresh in everybody's mind. So 5a squared plus 1 equals 126. I isolate my squared term, equals 125. Again, I attempt to isolate my squared term, and So A equals plus or minus 5. I square root this, plus or minus, this and this cancel out. A is plus or minus 5. Okay, now we're going to do number 24, and I'll do 26 too. So when we have 4 terms and we're asked to factor, first thing we do is we look to see if there's a GCF. If there's no GCF, we try to factor by grouping. So I take out a p squared, p minus 8, take out a 5, p minus 8. This becomes p squared plus 5 times p minus 8, p cubed minus 8p squared plus 5p minus 40, and it works. Okay, now 26. This is the difference of squares. Take the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. So I get n squared plus 8n minus 8n. They drop out, minus 64. Okay. Now, sketching a linear equation. It's been a while since we've done that. So let's look at number 30. 6x plus y equals negative 2. I'm going to put it into slope-intercept form. Y equals negative 6x minus 2. So my slope, negative 6 over 1. My y-intercept, negative 2. So I turn it over. I go to negative 2. I go down 1, 2, 3, 4, 5, 6, and over 1, and up 1, 2, 3, 4, 5, 6, and over 1. And this is what my line looks like. Okay, now if I did the cover-up method to try to do it from standard form, cover up, let x equal 0, negative 2, here is my y-intercept. If I cover up the y, x should be negative 1/3, and that looks close to being negative 1/3. Okay, so you can keep it from standard form and graph using the x and y-intercepts, or you can change it into slope-intercept form and graph by finding the y-intercept and using the slope to rise and run. Okay, so now we're going to do number 34. And 34 is y is less than x plus 5. So to graph an inequality, I write the equation that's going to be my borderline. My borderline is going to be dashed because equality is not a possibility. I go up to 1, 2, 3, 4, 5. I rise 1, run 1. And I make a dashed line. So this is going to be my dashed line. And now I'm going to shade either above or below. Since it's less than, I shade below. To make sure I'm right, I test the point 0, 0. And is 0 less than 5? Yes, it is. So I know 0, 0 should be in my solution set. And I shaded the correct side. Okay. Now we'll go to 38, where we're going to solve a system of equations by substitution. Actually, we can solve it any way we want. But in this case, substitution looks the best. So, number 38, they tell us y equals negative 4 and y equals negative 5/4 x plus 1. If I let y equal negative 4, multiply every term by 4 to get rid of my fraction. Negative 16 equals negative 5x plus 4. Subtract 4 from both sides. Negative 20 equals negative 5x, and x equals 4. So y equals 4 and x equals 4. Make sure it works. Negative 5 plus 1 is negative 4, and y equals negative 4. So that works. Okay. Now, a compound inequality. Okay, we're going to do number 44. And this says negative 8n is greater than or equal to 48, or n minus 2 is greater than or equal to 7. So, or, keep that down. So I divide both sides by -8. When I divide, I change the direction of my inequality sign. N is less than -6, or N is greater than or equal to 9. And this is or, which means it fulfills one requirement that's good enough to get on the list. So greater than 9 goes this way. Less than -6 or
Dara
equal
Schwarzman,
to
would you please come to the
goes
office?
this way.
Dara Schwarzman, please come to the office.
And remember, that's what an or inequality looks like. It can go in either directions. Okay, so that ends this part of the packet.